Now let's think about operators. An operator is generally written with letters such as H or O, and indicated by a hat at the top of the letter. An operator acts on the function written to the right of the operator and create a new function. For example, if you have a function called f, the operator h acts on f to create a new function called g. Here are some basic operators often appearing in quantum chemistry. The first is the differentiation operators. If the function f contains only the variable x, it is represented by the ordinal differential d. If the function f consists of more than one variable, it is generally expressed as a partial differential. This is the operator of the summation of the second derivatives of x, y, and z, which often appears in the Schrödinger equation. This operator, also called Laplacian, is often expressed as the square of the del operator. When the differential operator acts on a function called f, f is differentiated and a new function called g is created. Just multiplying a number can be considered as the simplest operator. For example, if you multiply f by 1, f does not change, but if you multiply by 100, the function g is 100 times f. Another simple operator is just multiplying a function. For examples, 1/2 kx squared and 1 over the square root of x squared plus y squared plus z squared. These correspond to the operators that represent harmonic vibration and Coulomb force. Let's practice a little bit to get used to operators. The question 2 is that what happens the operate h hat, when the second derivative operator of x, acts on the function of f, which equals x squared. After f is differentiated twice, the answer is obtained as 2. The question 3 is that h is the sum of the second derivative of x and y, and what happens after h acts on the function f, which equals 4x cubic y squared plus 5x squared plus 1. Because it is the sum of the two operators, two terms are created for the x derivative and y derivative. The first term is a partial differential of x, so we focus only on x and y is treated as a constant. Similarly, the second term is a derivative of y, so we focus only on y. Finally, adding the two results yields this answer.